Okay.
Oh, yeah, and share screen.
Thanks, Luke.
Hmm.
Okay. So this is a class on climate change. What have you guys learned so far?
Weather patterns and like low pressure and high pressure systems.
Okay, all right. We know low pressure and high pressure. We know like the hat and the rocking chair. Right, okay, good. What's the most important thing you've learned so far?
About climate change and about like weather and kind of how it happens.
How it happens. How does climate change happen? How does human caused climate change happen?
Okay. It's caused by the Anthropocene, I see. And
That's all of us.
what?
That's all of us.
Yeah.
Okay.
And what happens is the sustainability we've been taught is the overconsumption of resources leads to us producing the carbon combustion. I would say it better, but
We overuse resources. One of those resources in particular, you said the big C word. What's the word? Thank you. I just said the C word and then I realized, oh crap. Somebody's gonna say the C word and then I'm gonna get fired. Okay, carbon. Why is carbon not such a great thing in our atmosphere if we're trying to keep our lower atmosphere from warming up?
Does it trap heat more?
It traps heat more, right? Heat comes down from the sun, it radiates off of the earth, shortwave, long wave. You guys learn the difference between shortwave and long range radiation, right? Okay, all right, cool. All right, I get an idea of where you guys are at now. That's gonna help me out a lot. My name is Matthew LaPlante. I started my career as a journalist. I came to Utah about 20 years ago to work for the Salt Lake Tribune. I covered many different things, but mostly military and national security issues during the first few years of the wars in Iraq and Afghanistan. And then I decided, man, that's depressing. I should cover something else. And so I went to my editor and I said, hey, listen, I've been covering all this depressing stuff for a while. I'd like to write about something else. And he said, like what? And I said, like baby animals. And he said, we don't have a baby animal reporter. Go back to being in the military and homeland security reporter. So,
Don't know what is going on.
okay.
Sometimes this thing hates me. I'm
Do
sorry.
I need to keep it? I probably need to keep it active, right? Like,
No,
doing this?
it's just turned off for
okay.
no reason. See?
It crashed.
Maybe it's too much pressure to be in your presence.
Yeah, that's it.
Okay. Okay, sorry. Now we're good.
Okay. Okay. And we're still on Zoom? We're still recording? Okay. Right. So he told me, sorry, you can't do that. And so I said, okay. I went back to my desk and the next day I came back to him and I said, hey, I still want to be the baby animals reporter for the Salt Lake Tribune. I want to cover all baby animals all the time. That's all I want to do. And he said, get the hell out of my office. And then I went the day after that, and the day after that, and the day after that. I went several days in a row. And finally he said, look, you're not going to let this go. It's fine. You have to continue writing about the wars in Iraq and Afghanistan, but you can also write about the zoo in Salt Lake City, which is where the baby animals happen. So I got to meet baby elephants and baby penguins and baby monkeys and baby camels. I could meet all of these great baby animals. Okay. But the joke was on me because I was looking for something that was less depressing than the wars to write about. And guess what? Zoos are super depressing places. Super depressing places. The animals die, they get sick. You know, there's like they're taking care of some endangered animal, and then all of a sudden they come in one morning, they open the cage, and the endangered animal is gone. And terrible. So it didn't help my mood, but it did connect me to something that I had felt like for my entire life that I wasn't really connected to because I didn't feel like I was good at science. In fact, I felt like I was really bad at science. And as I was interacting with these animals and their keepers and the scientists that come into and out of the zoo to do research on them, I was learning that I had a real botanist bill for biology. And I thought, wow, this is something really cool. So that's actually how my career as a science writer began. And I began coordinating with real scientists to write books about the intersection of science and society. Most of those books were about health science. But increasingly my appetite for biological sciences grew. And in 2019, I published my first solo book. It was called Superlative, The Biology of the Extremes. And it was a book about how record-setting organisms can help us understand our world. And so I got to hang out with even more animals, elephants, whales, cheetahs. I got chased by a cheetah. You guys know that the cheetah is not the fastest animal in the world? You know who is? Me, when I'm being chased by a cheetah. No, also not true. The fastest animal in the world per its body size is actually a little tiny, as far as we know, is a little tiny mite. A tiny, almost microscopic animal that compared to its body size, if you like blew it up to the size of a human being, it would run 1,300 miles per hour. And actually running is a misnomer because it doesn't run, because the difference between running and walking is what? You know what the difference between running and walking is?
You have to have one foot on the ground.
Yeah, if you're a walker, if you're an Olympic walker, that's an Olympic sport, by the way. Walking is an Olympic sport, but the rule is you always have to have at least one leg on the ground. This mite moves the equivalent of 1,300 miles per hour, which, for context, most planes cannot fly 1,300 miles per hour. They would fall apart. It walks because it always has at least one leg on the ground at all time as it's moving the equivalent of 1,300 miles per hour. Cheetahs don't go that fast. And then one day I was hanging out with my friend Simon and his friend Lucy. And Simon and I started here at the same time at Utah State University when I became a professor of journalism and he became a professor of climate science. And Simon had emailed me when I was in Vietnam at the time and he was in Taiwan at the time. And he said, hey, I want your help with a research project. And I said, I don't know anything about climate science. And he said, no, that's okay, no big deal. You don't need to know anything about climate science. You just know about communication. I know about climate science. We're going to make a really good team. Also, I already forged your signature on the form, so you're already part of the project. And I said, okay, well, who's the project for? And Simon said, it's for somebody very important. And I said, oh, okay, well, maybe we should talk about this before I commit to it. And he goes, no, you're already committed. You're in. But we'll talk about it when we both get back to the United States. So we got together over coffee. And Simon brought his friend Lucy to coffee. And they got there a little earlier than me, and Lucy had only been in country for a few days. And so she was still getting her bearings. I showed up on my Harley Davidson with my motorcycle jacket and a helmet. And I walked into the coffee shop with my, jacket under my arms. And as you can see, I'm kind of tatted up and I've got bald head and earrings. And Lucy, Simon's told this story a million times now. She tells it better than I can. But Lucy grabs his arm and says, a bad man is coming. And Simon assured Lucy that it's not a bad man. In fact, it was his friend Matthew. And that he was here to talk about this climate science project that we were going to work on together. So I came into the coffee shop on that day and I said, okay, Simon, what's this project that you want me to be involved in? And he explained it to me and it sounded really interesting. And I was like, I'm in. And the conversation took like 5 minutes. Well, we had scheduled like an hour to be together. So now it was just time to catch up. And Simon said, hey, what have you been up to lately? And I said, well, I'm kind of thinking about going back to school. Because I never got a PhD. I wound up in academia because I was a professional journalist and I had had some success as a journalist and author, but I'd never gotten a PhD. And I thought, maybe I'm going to go back to school and then I can stop correcting people when they call me doctor. I can say, oh, no, not a doctor. But now I can be like, yes, which I guess is cool, right?
It is.
Lose a recently minted doctor.
Yes. It's
Okay,
so cool.
so he's like, is that seriously the reason why you want to go back to school and get a PhD? And I said, honestly, yeah, that's why. He goes, you want to go through years and years of additional schooling so that people, when they call you doctor, you don't have to correct them. I said, yes. And he said, you're crazy? Is correct?
Yes.
And he said, I also want to help you do this. And I said, oh, great, you can write me a letter of recommendation for graduate school. And he goes, no, I want to be your advisor. And I said, oh, Simon, that's really funny. Because you seem to think that I want to be a climate scientist. No. What I want to do is get a doctorate in something that's going to be really easy for me, like journalism, because I spent my entire career as a journalist. And Simon goes, well, why not climate science? And I said, Simon, I'm not a scientist. I write about science, but I'm not a scientist. And he goes, why not? Why don't you want to be a scientist? And he goes, and I said, Simon, that sounds really hard. What you do sounds hard to me. And then you know what he said? That bastard. He said, you're always complaining that your students are unwilling to do hard things. 5 minutes, you guys. It was a 5-minute conversation, and I committed to the next 4 years of my life studying for a PhD in climate science. Don't make decisions that way. Don't do that. That's really stupid.
Is that hard?
It's been hard. It's been hard. It's been hard.
I know.
Okay. But now I just a couple of weeks ago finished my exams. I will be defending my dissertation in May or June. And then when people call me a doctor, I will be able to say, yes. And all of my research up until this point and everything that I will be doing as a climate scientist moving forward is based around something that Lucy told Simon on that same day that I decided that I was going to be a climate scientist, not even knowing what the hell a climate scientist does. Lucy was freaked out because she thought a bad man was coming. I'm going to phrase this in a little different way than Lucy did. Scary things are so scary. Whoa, we got to change that. I just wrote this today. This is better, makes more sense. There we go. Okay.
Just come back with you.
Scary things are not so scary when we know what they are and we can see them coming. Because once Lucy met me, she knew I wasn't a bad man. I only looked like a bad man. But Simon assured her, he reassured her, I know this guy. And yeah, he's kind of an asshole sometimes, but we know how to handle him. Scary things are not so scary when we know what they are and we can see them coming. This is the driving sentiment behind all of the research that I'm doing as a climate scientist, and I will argue most of the research that most climate scientists are trying to do all the time. You guys hear scary stories about climate change all the time, right?
Remember, don't be depressed.
Drought, floods, tornadoes, monsoons. The world is heating up and there's nothing we can do about it. And then the alternative to that, the other story that you hear is what? Climate change is not real. Those are the two choices that you've been given. And it's really no wonder, at least in my mind, it's no wonder that so many people have chosen to believe that climate change isn't real, that humans aren't causing it, that this is all just part of a natural cycle of things, because the alternative that they have been given is to believe that we are marching toward our doom. Hell, why not just say, it's not true? Because what can you do about it? We feel hopeless. We feel helpless. We feel like the world is going to end. We don't have to feel that way. And we also don't have to deny the science, which is compelling and accurate and almost universally agreed upon by climate scientists, by the people who study this stuff for a living. Climate change is real. It is human caused. It is happening. And yeah, it's bad. But also, guys, we know it's coming. And if there's one thing that separates human beings from every other species on this planet, one really important thing is that we are intentional adapters and even proactive adapters. When we see bad things coming, we can adjust. And right now we know that this bad thing is coming. So to talk to you guys today a little bit about, I keep going the wrong direction here. this idea. We don't have to stop believing in science in order to have an optimistic view of the future of our species under climate warming. I am a climate scientist who has an optimistic view of our future under climate warming. And in fact, I have a more optimistic view of our future under climate warming than I think I would have if I really did believe that climate warming didn't exist. Because climate is big, it can be destructive, it is highly variable, as you've learned in this class, and it can be deadly. Just natural climate variability, the underlying ebbs and flows of climatological variables can be dangerous. But we have an impetus right now, our entire species, hundreds of thousands of global leaders, tens of thousands of scientists, millions, hundreds of millions of people have an impetus to understand climate right now. And we're going to have the upper hand. I know that's crazy to talk about, but I'm going to give you some examples of why that is, why I believe that is. We're going to do this in 3 chapters today. I'm going to talk mainly about one chapter. East Pacific ENSO offers early predictive signals for harvest yields in the wheat state. This is a very scientific way of saying ocean temperatures help us understand farming better. You guys have been in this class long enough to know what ENSO is, I think. ENSO?
I don't think so.
No? Who can tell me who just happens to know ENSO? Ah, okay. When I talk about ocean temperatures, and I talk about phenomenons in the ocean that affect weather patterns elsewhere in the world, I'm probably talking about. That's right, the El Nino, EN, El Nino, Southern Oscillation. That's El Nino, La Nina, and the phase in between, which I call no Nino. Everybody else calls it the neutral phase, but I like El Nino, La Nina, and no Nino.
The recent marriage.
What's that?
Recent marriage.
Yes.
Later, no, yeah.
Okay. Oh, I keep going the wrong way. All right. So I'm going to explain something to you very broadly about El Nino and La Nina, and the impact of La Nina and El Nino on North American weather patterns. Okay, so during El Nino, okay, which is warmer than average temperatures in the equatorial, central, and east Pacific. So from the kind of border of Peru and Ecuador, all the way across the ocean to about the central part of the ocean. Okay, warm. Am I going the wrong way? Thank you. I appreciate that. Okay, from here to here on this map. Okay, all right. During warmer than average temperature fluctuations in this part of the world, in general, broadly speaking, what we see is colder and wetter temperatures here, and warmer and drier temperatures here. And then there's a space in between that we're going to talk about in a moment here. And then, sort of vice versa, more or less, and I'm talking really broadly here, okay? Like I am like painting with a really broad brush. But during La Nina, which is colder than average sea surface temperatures in that same place, we've got colder and wetter temperatures up here, or weather up here, and warmer and drier weather down here, and then this sort of area in between that we don't know quite what to do with. Okay, and there's a lot of reasons for that, and you guys are going to talk, I understand, about oceanic atmospheric connectivity next week. So right now, just you guys take it on faith. Can we take it on faith for a moment? That this is broadly speaking what happens? Okay. Now here's the problem. If I'm the kind of person who tells you things like, you don't have to stop believing in science in order to have an optimistic view of the future of our species under climate warming, and scary things are not so scary when we know what they are and they can see them coming. And then I tell you, there's this big part of the United States that we don't know what happens when there's an El Nino or La Nina. This is a problematic area, isn't it? It's particularly problematic for those of us in Utah, because what's right about right there? That's us. That's us. Utah is in this liminal band of space between the most predictable effects of El Nino and La Nina. So it was Northern California, Nevada, Colorado, and this state right here, which you can't see, Kansas. So this is a really interesting area for me, because if we can figure out how to predict climate, weather and climate in these areas better, then we've substantially closed the gap. And now all of a sudden I've got answers for people in Utah. So right now I talk to farmers and they're like, well, El Nino and La Nina don't affect me. And you know what? They ain't wrong. Farmers in Utah, farmers in Kansas, according to the science right now, aren't wrong. We're not actually sure whether these climate oscillations that affect kind of everything else on Earth in one way or another, how they affect all the things that happen in this area of the United States, in the liminal band. So I was doing some thinking about, like, how do I talk about this to people? What's a good way to talk about the idea that if you can see scary things happening better, you can plan better, you can prepare better, and you can not only not be scared, but you can actually thrive. Well, farming seems like a good area to do that, right? Like, let's think about this for a second, right? If I know that an area of the United States is going to become far more drought prone under climate warming, if I've been farming there for generations and generations, what might I want to start doing? I've been farming in this area for generations and generations, but it's about to be really droughty for a really long time. What could I do?
Save water.
I just save water? Okay, what else could I do? Go ahead. No?
Yeah.
Sir.
It's the same story of Joseph in the Bible. You're gonna start stockpiling,
Okay,
rationing.
good. You can stockpile and ration. What else? Could make more. Oh yeah, I could start using my land for something else. Okay, I could move. I could
Like if
pick
you
up.
can try to decide or search for certain groups of wheat that they are more resistant in the drought conditions.
Sure can, right? I can start thinking about what I need to plant here. Maybe I'm going to choose a different crop. Maybe I'm going to choose a different time of year. Maybe I'm not going to do things the same way that my family has been doing for generations and generations. But in order to know that, I need some predictability.
Method.
Yes, sir.
The problem with that though is now that we have more like newer like plants, and some plants have like genetic codes that companies own. If you do that and use something else's and you have a contract with them, they might sue you.
They might do that. That is true, right? So we can talk about genetic patents in another class. Okay. All right. So look, if I can see something coming, but here's the problem. So when I think about farming, I don't know why, because I'm not a farmer. Okay. I think about the state of Kansas. I think about the state of Kansas, and I think about this woman, Catherine Bates, who in the 1890s was on a train trip across the United States, looking out her window, and was moving across the state of Kansas in the 1890s, generations upon generations ago. And what did she see? You guys know the song. You guys want to sing it?
No.
Yeah, let's be super patriotic. No, just the first few verses. We don't have to stand up. Do you guys want to stand up? No, but we're gonna sing it. Okay? I appreciate it. I appreciate the enthusiastic head nod after the note. I really do. Oh, beautiful. For spaceship skies, for amber waves of grain. You guys are terrible at stop. Okay. For generations upon generations, Kansas, which has several nicknames, one of which is the wheat state, has been the center of wheat production in the United States. It is also in the center of that liminal band where science tells us right now, we're not really sure what the effects of El Nino and La Nina are. It makes it less predictable. So that's not great, because we can't see the thing coming. So I wanted to explore this a little. And the way I explore this is really, really simple. Like a sixth grader can do this science. I got records of wheat yields in bushels per acre. A bushel is 60 pounds of wheat. So I've got records of wheat harvests in bushels per acre from the United States Department of Agriculture for the state of Kansas. And not shockingly, way back when Catherine Bates was writing about amber waves of grain, we got like somewhere around 14 or 15 bushels per acre. But there was a lot of variability. You can see like between just in this little span of time in the 1880s, 1 year, just a couple of years after another, there's more than a 200% variability. So sometimes we have good wheat years and sometimes we have bad wheat years. And that continues. Good years, bad years, good years, bad years, good years, bad years, good years, bad years. But what's happening here? Yes, sir.
So the drasticness of the good years and the bad years are getting further apart.
That is true. So there's more variability. We see there's a huge variability here. So that's one thing. We're seeing that. What does this happen? Why is this happening? Why is this slow? Because so now we have years that we have 57 and a bad year is 28 bushels per acre, but that's better than a good year back in the 1890s. Why would that be? It's gonna pick on somebody I haven't picked on yet. Why would that be?
Better equipment.
Better equipment. Good. What else? You just talked about it.
Yeah, so like better technology and so on.
Better technology, but you said something about seeds.
Yeah, we modified the seeds.
Genetic modifications of seeds?
It's not only a thing that we just mentioned about to better equipped with technology, it's because of many things. For example, the experience of farmers, technology, better seed that we used every year, and water efficiency in irrigations.
Perfect.
Yes, many things that we can mention. Or maybe for this specific area, maybe need to more study about to ensure.
It's like you read the introduction to my paper. It's all of these things.
Alejandra also wants to say something.
I was just gonna add, yeah, like reminds me what they're saying is reminding me of the Green Revolution, just like overall.
That's absolutely right? We see better productivity, more, and better is sort of subjective, more productivity as we go along, as a result of better technology, better harvesting, better irrigation is huge in this, right? Getting water where it needs to go more efficiently, right? Both in good years and bad years, getting water where it needs to go more efficiently. Pesticides, herbicides, not just that we can apply on the ground, but now we can apply via airplanes. What happened right around here? What did we get? Airplanes, right? So lots of things happen. It makes this index really hard to work with because I can't compare. This is a bad year now. It would have been a good year back then. So statistically, anybody take statistics? What do I need to do this? No statistics? You guys haven't taken statistics yet? Stats yet? Okay. That's okay. We're going to do a little stats class here really quick. We're going to detrend it. Okay. So we're going to take out, we're going to take this and we're just going to tilt it this way. And the way that we did it for this study, there's a lot of different ways that you can detrend data. But the way that we did it was really simple. We took out these 30 years at the beginning of the time series. And we created a running mean. What is the average? At the end of 30 years in 1895, what was the average? And then we just divided that annual into that average so that we knew what the annual was in the context of the period that preceded it. So now we know what a good year and a bad year is in the historical context, in the technological context, and also the great benefit of this is that climate variation, right? When we're trying to, you guys probably learned this in this class, right? If I'm trying to figure out if global warming is happening, should I look at the years 2018 to 2023? How about 2013 to 2023? How many years should I probably look at?
At least 30 years.
30 years. 30 years is the magic number. Guess what number I use here? 30-year running mean, right? So that's going to smooth out also that climate variability so that we can see what was really a good year and a bad year in the context of the time period that it happened. And we can still see all of this, like a lot of variability. And we can see now what a bountiful year looks like and what a meager year looks like in this index. Now, once you have an index, the really cool thing about having any index is you can compare it to any other index. This is an annual index. This tells me wheat yields at the end of the wheat harvest in all of these years. And now I can compare it to other indices and do a really simple correlative assessment. What? Wrong way again. And that's what we did. And this got really messy. But what we can broadly see here is looking at an index called the Best INSO index. These people were so smart, these scholars, they're like, you know what? We really want people to use our index to measure El Nino Southern Oscillation. What acronym will we use? We'll call it the bivariate INSO something. I don't even remember, but anyway, the acronym they came up with was BEST. So now anytime anybody uses it, they have to say, well, I use the best index. It's actually not. Kind of a shitty index. No, it's not a shitty index. It's a wide-ranging index that tries to extrapolate whether there was an El Nino, a La Nina, or a No Nino, okay, in this really large part of the ocean and the atmosphere that it interacts with. Okay, all right. And it's pretty good at that. And also, as it turns out, and you can kind of see this in the data too, right? You see like, oh, okay, so when the wheat index, that's in brownish here, wheat brown, we're gonna go with that. When the wheat index goes up, the best index goes up. When the wheat index goes down, the best index goes down. And they're not perfectly aligned, but we see a high degree of correlation in the same year. Pretty good statistical significance in the same year. Any farmers here? Anybody know how long it takes to grow winter wheat? I like this guy a lot. Okay, it takes winter, but unfortunately it takes even longer than winter. Winter wheat is a 9-month crop. Okay, so knowing that there is a year-to-year correlation between the state of INSO and wheat harvest is interesting, but not super helpful because it's basically just telling you once the wheat is in the ground what's going to happen. And, you know, within statistical significance, but this is by no means a guarantee of what's going to happen. So, interesting, probably not actionable. And by the way, that's what the farmers in Kansas have told me about this too. Oh, that's interesting. And also, thanks for your time, sir. Also, when I go to talk to farmers in Kansas and I introduce myself as both a journalist and a climate scientist, the guns come out. Figuratively. They were very nice. Just have some differences of opinions.
They went to Kansas.
Okay. All right. If we go a year back, the correlation disappears. Absolutely non-existent, not statistically significant, completely useless. So interesting, not actionable. We go 2 years back, forget it, right? But this is really the time frame that we can have some action, that this could be meaningful, right? That it could allow farmers to start thinking about conserving water, whether they're going to irrigate, what kind of seeds they're going to use. Or am I going to use a seed this year that is better for drought, but has less yield? Or am I going to use a seed that's better for pluvial years, wet years, and has more, but is prone to infestation? They can start making decisions if we can get them information before they plant. Information while they plant is helpful, it's interesting, it's not going to be a game changer. This is a really big area though. Really super big area. Okay. And we have these different reference regions in this area. We've got Nino 4, which is like what we call, so when we have an El Nino in the Nino 4 area, we call that a Central Pacific flavored El Nino. Believe it or not, we talk about El Nino and La Nina like they're ice creams. We call them flavors. So that's a Central Pacific or even a Western Pacific flavored El Nino. And then if it happens over here in Nino 3 and Nino 1-2, Nino 1-2, by the way, is the area where El Nino was first discovered by fishermen off the coast of Peru and Ecuador. Okay, we call this an Eastern Pacific flavored El Nino, and there's been lots and lots of attempts to try to categorize, because we got to categorize and label everything in science. There's been lots and lots of attempts to categorize the different kinds and flavors of El Nino and La Nina. We'll get into that in a little bit. Okay, but the important takeaway right now is that this is a really big area. So what if we look at all of these as individual indexes? Instead of looking at the best index, let's look at them individually and see what we see. Well, as it turns out, there is an index that is more strongly correlated to eventual wheat harvests in the state of Kansas than any of the others. It's that little tiny one right here, which is also the historical origin of La Nina and La Nina, where we first discovered El Nino way back when it was just like, wow, there's more fish here. Huh, interesting. What's going on? Well, what was going on was warmer seas and differing patterns of ocean currents and winds that created that environment that created for, you know, warmer waters and more fish. But this is interesting because this correlative association, I don't have these side by side, so take my word for it. This correlative association year to year is better. And in year 2, it's still not statistically significant, right? At the point that we want it to be, to make it anywhere near actionable, but it's way up from what it was, right? The other one, a year before, almost non-existent, completely statistically insignificant. And here we're like, something's happening. It could be nothing. Correlation is not causation. You guys have heard that before, right? Correlation is not causation. Could just be statistical noise. And in any case, 3 years out, forget it, no correlation. But this is getting interesting here, because what this tells me is that maybe if there is some kind of connection, we're going to be seeing it right here in the Eastern Pacific. And we're going to be seeing it potentially with enough time to let farmers know what's about to happen. What's more likely to happen, not what's about to happen. We can't prognosticate the future. All right, so what did we do? We said, let's take a bunch of different Nino indexes. All the ones and more, actually there are more, there are like this many. But let's take a bunch of different INSO indexes and let's compare them to the wheat yield index and let's see what happens. Well, so you can think about this like this is harvest season right here, okay? And this is back in time, okay? The past, the future, the past, the future, the past, the future. Wheat harvest happen usually in midsummer, okay? And as we can see that like when the harvest is happening, there's really not many associations over the long haul. This is like 30 years of data. Okay, well, actually it's 50 years of data, 50 something years of data. Okay, over 50 years, once harvest arrives, most of the indexes don't tell us shit about whether or not the yield is going to be good or not. But that little one does. Not shocking, because remember we saw this was a lot higher, a lot more statistically significant. Okay, so Nino 1-2 tells us a little more on harvest, but again, like that doesn't help us. Like, ooh, at harvest, we know how good our harvest is. You know who already knows how good their harvest is? The farmers, because they're harvesting. They already know. They've been walking the fields for a while at this time. They're like, it's going to be a good year, or oh shit. Okay, we start going backwards in time. And what we see is that pretty consistently, Nino 1-2 has the highest statistical correlation to eventual wheat yields. 3 months ahead, 6 months ahead. When do we plant winter wheat? How many months ahead? 9 months ahead? A year ahead? We're going back in time, and at each of these steps, we're getting further back from the harvest, and we're getting further into times where we could make actionable decisions about what we're about to do. Now, again, correlation is not causation, very interesting. Couple of things that make me go, ooh, I like this. Here in bold are the most statistically significant relationships are in bold. Right here, right here, right here, right here, right here, right here. Nino 1-2 is consistently the most statistically significant relationship, not just one season back, but season after season after season after season. That tells me something. Next off of that is what though? Somebody read the numbers. What's the next one? If I didn't have Nino 1-2, but I wanted some clarity on what's going on here. What are the next biggest numbers? Nino 3. Okay, you guys can't see it very well. Let me see if it's okay. What's right next to Nino 1 and 2? Nino 3. Nino 3. There's something happening in the East Pacific, or appears to be at least. Because Nino 3 is the next closest to that, and it also has the next highest relationship fairly consistently. Okay. So, and what I can see is over time, these relationships, they wax and wane, they go up and they go down. Sometimes the relationship's stronger, sometimes the relationship's weaker. This is statistical significance. And as we can see, Nino 1-2 consistently over time, that's the red, by the way, consistently over time maintains a pretty substantial relationship with wheat harvest yield. And it has especially done so in the last 50 years. A period of time why the way that we've seen the greatest amount of global warming. And then right below it, INSO 3. Okay. So maybe, just maybe, we have a little more data here. And I will tell you what a little more data means for a farmer. Again, I'm not a farmer, but I learned to talk like them. I like these guys in cannabis a lot. I told you, I'm a journalist and a climate scientist. Okay, these guys are, broadly speaking, I'm going to speak with a very broad brush. First of all, I'm going to call them guys because most of them are. Okay, and second of all, I'm going to tell you, I didn't meet a single one who didn't vote twice for Donald Trump. Okay, a lot of them were wearing MAGA hats, and a lot of them told me the first thing they told me, climate scientist and a journalist, ooh-wee. They just kept saying, ooh-wee, which I took to mean F you. But they were nice. They invited me into their homes, into their offices, into their tractors, into their fields to go and see things. You know why? Because even though these guys, they don't trust climate scientists, let alone climate scientist journalists, they want an advantage. And if I can help give them something that based on the data, by the way, that they have provided to the United States Department of Agriculture for 100 and something years, what the data tells me is that at a period significantly before you start to plant, you start to sow your field with wheat seed, we can have a little bit better indicator of whether it's going to be a good yield or a bad yield year. They like that a lot. They don't need to know that climate science, climate change is real or it's human caused. They don't need to know that. What they want to know is, can I act on this? Will it help me make decisions? And in a world that, by the way, they pretty much agree is warming. They might disagree, some of them, many of them might disagree on why it's warming, but they pretty much agree. Like they see it, they know. Right? They've got thermometers in their yards. They know that things might get harder for them in the future. They want every advantage they can get. One farmer I went and chatted with was showing me the weather app on his phone. He's been farming the same land for his family's been farming the same land for generations and generations. And he's like, when I was a kid, we'd wake up, we'd go do the farming stuff, then we'd come back for lunch and we would read the paper and see what the weather report was. And then we'd sit around and we'd go, well, what do you think? What do you think we should do? And he said, now we don't do that anymore. First thing I do when I wake up before I even get out of bed is I turn on the weather app. And I start thinking with greater certainty about what I need to do today based on what the weather is going to be. That science, by the way, the science that allows us to know what the weather is going to be, isn't all that much more complicated or all that much more accurate than what we're talking about right here. You guys have all had the experience of waking up, having the weather person tell you one thing and then going out and that wasn't what happened, right? But we still make decisions based on it. Weather person says there's a 50% chance of rain, you're like, well, I'll bring an umbrella. Weather person says there's a 5% chance of rain, you might not. Even though we know that 50-50, 5%, it could still rain. Yeah. Right. And that's what all of these guys told me. All of these farmers told me again and again. If this is actionable, if it is something that helps me grow my crops, if it's something that helps me produce greater yield in a time of greater climate uncertainty, I'm interested. I didn't need to convince them that global warming is real. Maybe someday I will. I only had to convince them that there is potential that this could help them. They were interested. Okay. So keep doing that. So what we should expect to see based on this data, is that in bountiful years, we're going to see an Eastern Pacific El Nino. And in meager years, we're going to see an Eastern Pacific flavored La Nina. So we'll just take two of them. I told you guys earlier about these 2 years, just a couple of years apart, one bountiful, one meager, 200% difference in yield, 200% variability in yield. Well, what did those look like? Well, it turns out the bountiful harvest, exactly what our long-term data told us to suggest. Then moving back, and again, we're going to go February, March, April. Yeah. Okay. Future harvest time, past. Not much here, not much here. Oh, look what we're seeing in the Eastern Pacific, in the Eastern Pacific, in the Eastern Pacific. Moving back, before this really good harvest, we saw the thing that we suspected we would see. And in 2014, not much here. Oh, something's happening, something's happening, something's happening, something's happening. We saw the thing in this case study year that we suspected that we would see well before planting season. And then we could do these for a number of individual years, but also I took the 10 best harvests and the 10 worst harvests over in Kansas. This area, by the way, remember, this is the liminal band, right? The area that we don't really generally associate with any significant predictability in whether INSO is going to affect weather. We took the 10 best and the 10 worst harvests, we shoved them all together. Lou helped me with this. Thank you, Lou. And what did we see? Exactly what we suspected we would see based on that data, based on those correlations. Eastern Pacific oriented El Nino and La Nina phenomena that are precursive, come in advance of good harvests and bad harvests, good harvests and bad harvests. Does this guarantee a good harvest? Nope. Does the El Nino guarantee a good harvest? Absolutely not. Does the La Nina guarantee a bad harvest? Absolutely not. These are not predictions. These are data that we can use to better our chances. We already do all kinds of stuff like that. Farmer wakes up, he sits in his tractor and he goes, I just feel like today would be a good day to plow. A lot of these guys, they just feel like it's going to be a good day to plow. They got something, right? But they'll use little tiny pieces of data, sometimes so minute that they can't even express what they are to make decisions. And more often than not, they're right. And the reason that they do that is because more often than not, they have been right. This is how farming happens in the United States of America and everywhere else on our globe right now. We use roughly the same seeds. We plant on roughly the same acreage. We respond to drought with irrigation if it is at all possible. We respond to infestations with pesticides if we need. And we do it pretty much the same way year after year after year after year. And the result of that is that we're going to have, in a place like Kansas, which over the course of 150 years has been generally better for wheat than it hasn't been, we get more good years than bad years. In the good years, we make a lot of money. And in the bad years, we receive crop insurance. We fallow our field at the point that we kill our field off at the point that we realize we're not going to make any money on it. And the American taxpayer helps pay our bill. And in the neutral years, you kind of break even. And you got more good years than bad years, and this is the business plan for farming, broadly speaking, hitting with a real broad brush here. Okay. Those insurance payouts, by the way, in 2001, they're $2.96 billion. By 2022, they're $19.13 billion. Sorry, that's not the payouts. That's what the American taxpayer paid to subsidize the payouts for, in addition to the payouts that the insurance companies were paying. $20 billion a year, up, I don't know how many hundreds of percent in the last 20 years. Crop insurance has gone up, right? So we all pay for it when farmers have a bad year. And that's important, because honestly, you guys want them to stop farming? I don't. Wheat's kind of important.
Electricity and bread.
And bread and all of it and pasta and all that other stuff that we make with wheat, right? It's kind of important. It's a significant part of our calories. We need them to be able to make these bets year after year. Right now, we do that by subsidizing when they have a loss. But let's suggest something here. Let's suggest that in some years, we know ahead of time with a greater amount of certainty, not a certain amount of certainty, right? But a greater amount of certainty, we know that it's going to be a really bad year. We have, let's just say, a year, 15 months, 18 months of advance notice. We could potentially ask farmers, hey, would you be willing to take your payout now to follow your feeling in this year? Take your insurance payment now. Don't plant. Don't use water. That's going to leave more water for those farmers who need it this year to irrigate if it is indeed a droughty year like we think it's going to be. No expense for seeds, no expense for fertilizer, no expense for pesticides, no expense for herbicides, no expense for the pilots that fly those things over the fields. And by the way, enjoy your vacation in Tahiti, because Tahiti is a magical place. We could potentially increase the ratio of good and neutral to bad years in this way. Now, it's a little crazy to say, like, I've solved all farming problems. We haven't solved any farming problems, right? This is super initial exploration and data, not even published yet. Just finishing the revisions now. The reviewers liked it though. They just want more because reviewers always want more. Okay. This is how much time do we have? We're almost out.
We have more 15 minutes.
15 more minutes? Okay, cool. This is, you guys, this is one of the reasons why I feel really confident. One of the big things that we talk about when we talk about anthropogenic climate change and the risks that we face, which are real, is the risk to agriculture. This is one crop in one place in the world, which, by the way, we've always accepted has very low INSO predictability. But maybe it doesn't. And if I can predict crops in this area with a higher degree of accuracy, if I can give farmers a better ability to create more grain in good years and bad years, in a place in this liminal band, what can we do in places that aren't so liminal with the same kind of data? We worry so much, rightfully so. We worry about the future of agriculture under global warming. But this is a simple analysis. I told you, a sixth grader could do this. I really believe this. A sixth grader could do that. Now, my sixth grader, when she was a sixth grader, is like the smartest sixth grader ever. But just saying, okay, I'm not that good of a climate scientist. I'm a much better journalist. Simon made a big mistake in inviting me to study with him at this fine university. Huge mistake.
No.
Okay.
Hey guys, it takes more than data analysis to be a good scientist. You need to be able to communicate science, and you do this. So, yay.
Yeah. So, all right. I was going to tell you guys 3 chapters. I kind of went a little long on Canvas Wheat. I do want to leave a little bit of time for questions. So I was going to tell you about our major winter here and why it was completely. This is the North American Multimodal Ensemble forecast. Okay, this was the January forecast for February, March, and April. February, March, and April, the snowpack went crazy in Utah. 900 inches at our home. 900 inches of snow at our home. That's a crazy amount of snow. I was going to tell you about this study and about whether or not those kinds of years are predictable. And I was going to tell you about the Great Salt Lake and what we're learning about the declining of the Great Salt Lake, which is probably not what you have heard. You've heard this, right? We're all going to lose our Great Salt Lake. Maybe. Bottom line for that is we might not actually be able to fix this problem. And that's actually good to know. Because if we can't fix it, if this is more climate change than it is, we're just taking water off the lake, then we can plan. We can prepare for that future. All of these come under the idea that, oh, I don't have it here. Okay. Bad men aren't so scary if we know them and we can see them coming. Questions, comments, arguments, call bullshit. Tell me I'm silly to be optimistic. That's cool.
I will make a question, just to explanation and clarification to them. Can you come back to your the trend?
The trended data. Almost there.
Yes. So, just to contextualize how you guys got that already, because he asked and you guys answered. But basically, he created anomaly values to see how far from average and how close to average was. And you can see that all his numbers are positive. So like all positive anomaly. Can you go to the next figure, I think? And here you can see in the left hand that you have negative anomalies also, because this is the ends of flavor, the best ends of flavor. And the other side, you have only positive. Do you know why it only has positive anomalies? Because if you're calculating the hovers, you don't have a year that you have a negative hovers, like drought conditions when it comes to precipitation are colder than average. He always have cropping. They always get cropping. And the thing is, some years there are less, some years there are more, but always have. It's just contextualizing.
Well, I just wanted to comment, so, when you were saying, we can't predict whether it's gonna be exactly in that area, right, in that band, but in studying the data from the La Nina, El Nino effects, you can see the influences. And the farmers see that, but they don't equate it to science, right? Farmer's Almanac is just their grandpa before them saying, this is what happened every year. And can you see the pattern? And so, and that's how it's passed down, right? And all it is, right, you're gonna affect my pocketbook. So how do I lessen the effect of that? You know, how do I gamble and get the best results year in, year out, type thing? And so is it, when you say it's correlation isn't causation, it's just stretched out further. It's influence, right? So, and there is influence. You just can't tie it directly like these guys don't get any fish. You guys aren't getting any wheat. You know, we haven't pulled those two dots together. But
Let me pull a couple of those dots together really quick here. Let's see if I can find, nope. All right, not a great, well, as good as we're gonna get. All right, so. Chatting with a climate scientist whose expertise is in El Nino predictability. Her name is Michelle LaHaroux. And Michelle heard about this study And she was like, oh man, Kansas. She's like, what am I gonna tell them about Kansas? Because Kansas, generally speaking, is not connected, climatologically connected. Now remember that this effect actually weakens in the harvest season, right? And even like it's actually pretty weak for the first like this connection between Nino 1-2 and Kansas wheat yields. Okay. Because what we think is happening here, what Michelle and I think is happening here, is that there's not a direct teleconnection between this part of, ooh, is this a? Oh.
It doesn't show
doesn't
that
work
much,
though. Okay.
yeah.
There's not a direct teleconnection between this
But it's
area
just
of
what
the
you can
Pacific
do.
and this area of the United States. But what we do know is that Nino 1-2 signals often happen as precursive before larger and stronger El Niños. So what's happening, what we think the dynamical explanation is that the reason why we're getting such a strong signal here that affects here is that when there's a strong Nino 1-2 earlier on, it is more likely to lead to a stronger Nino or La Nina anomaly here. And that's the place that is really powerful for oceanic atmospheric circulation changes that impact weather in North America and push that liminal band away, right? Basically, like push up the La Nina effects or down the El Nino effects, or vice versa. That's the dynamical explanation that we think is at play here. Is that it's not like there's like this really crazy like sorcery that's going on.
It was my fault.
Sorry.
Sorry.
It's not like there's this really crazy sorcery that's going on. It's causing this atmospheric connection, at this, basically, a couple of lines of longitude over and a bunch of lines of latitude over, right? Like that doesn't make sense. But what would make sense is if this is giving us a signal about what's going to happen here in the rest of the ocean, and now we have this really amazingly powerful area that's being impacted. And now the circulations are changing as a result. The jet stream is changing as a result. You guys are going to talk about jet stream next week?
Yes.
Yeah. Okay.
More questions or comments?
I was thinking about like. Looking at like 1800s, like the crop yield and so on, but probably also affected his population. Because there was like this many people.
There were this many people,
Yeah,
right?
like, there wasn't many farmers, and then all of a sudden, when everyone started coming in, more farms got.
Well, the acre, so that's bushels per acre, so that's going to smooth that out, right? We don't have more bushels, and in fact, there's been times in our history where we've actually created more wheat, but we transport it differently, right? And so we don't need that, and that's why bushels per acre helps smooth that out. We're looking at apples to apples comparison there, but also, I mean, one of the things you said is absolutely right? There were a lot less people back then, a lot fewer people back then in that area of the world doing all of the farming.
If you have less consumption, then you don't need to
That's true.
have
That's
that
true.
much of.
Yeah, also record keeping was not as accurate. Like, what'd you get, Larry?
Yeah.
Right? Yeah. And yeah, despite the fact that record keeping wasn't as good back then, we see this like long-term association that stays pretty static over time. It's really interesting with precipitation records and all that.
We're still missing the hard questions. Where's the hard questions?
Let me ask you guys this. Who feels like, look, I'm not asking you to like all of a sudden feel like climate warming is no big deal. I want to make sure I'm saying like it's a big deal, right? But does anybody here feel maybe like a little better? Like, hey, wait a second, hold on. We can adapt, we can change, we can learn, we can grow, we can get better at the things that we do, we can predict. Yeah? A little? Okay, cool. What if I gave like 10 lectures like this? What if not this lecture, right? We already talked about this one, but what if next week, I'm not taking your class, I don't want your class.
You can take.
No, I don't want your class. No, but what if next week I came and I told you about how we can predict how much snow and water we're gonna get in the upper Colorado River Basin over the next few decades. And then I came and told you about how we can predict where wildfires are most likely to be. And then I told you, hey, we can predict where droughts are gonna be, we can predict what seasons hurricanes are gonna be stronger. If I gave lecture after lecture after lecture of that, we got 16-week semesters here, right? If I gave 16 lectures like that. They were all like this one. How would you guys feel at the end of the semester? A little better about the world? A little more like maybe we have the tools that we need to survive and thrive, even if climate warming is real, which climate warming is real. Yeah, me too. I go on sabbatical next year. I think the year after I'm gonna come back, I'm gonna give that class. You guys are still here, we're gonna do that class. Sound good? Cool. Cool. Question? Ideas?
Knowing it's always better than not knowing. If you know how it's taking a shot, it will be easier to you to take the next shot, or at least you will know that this is not a good day to work out your arms. So you can have the smart decisions, and I do agree with Matthew, like knowing what expectations we can have, it give us better perspective, better ideas, and how I told you before. Who knows if the next United States president is sitting in this class? You can have a broader perspective about how we can connect things. So no one is sad today. Everyone is pretty positive, right? That's a good goal.
You guys want to feel a little more optimistic? I'm going to give 2 recommendations. One, there's a book called How to Be a Climate Optimist. Look it up, read it. 2, if you're not a reading person, but you're a podcast person, I host a show called Undisciplined on Utah Public Radio, which Lou's a big fan of, apparently.
It's very good. It's very good because things that you don't think about it, he comes and talk about it. Is that what?
3 or 4 weeks ago, we did an episode on climate optimism, taking conversations from scientists who I've been talking to for years and years, and bringing them all together and explaining why I feel like a climate optimist right now. Why, despite the fact that I believe that global warming is real, that it is severe, that it's going to be with us for a long time, and by the way, it's not something we're going to mitigate our way out of. We're not going to stop it from happening. I feel good about our future. I think that episode was called it might have been called How to Be a Climate Optimist. But if you go to the page for Undisciplined on Utah Public Radio, you scroll down about 3 or 4 episodes there. Take you 24 minutes to listen to, and you'll feel better at the end of the day.
So thank you, Matthew, for today. Thank you, Matthew. I will stop recording. Okay.